Now that you're more familiar with ggplot and geompoint, we can try layering multiple graph types in one single ggplot canvas. So for example, we can layer a line graph on top of a scatter plot. Don't worry too much about geom smooth right now. That's what makes this line right here, but don't worry too much about that right now. This is only to show you how we can layer multiple geometric functions in one single ggplot canvas. And we will be covering more geometric functions in the later parts of the tutorial. Just note how, just like how ggplot is separated from the first geometric function with a plus sign, every other geometric functions that we layer on top of this ggplot will need to be divided or separated by plus signs. And here's another way for you to write the exact same code chunk as above. Now you can pause this video and read the little blurb right here, or you can compare and contrast the two code chunks on your own. In my opinion, the second one is cleaner and more organized, but the first one is much more straightforward and more customizable. But it is up to you which one you choose to regularly use, depending on which one you're more comfortable with. We can also write other geometric functions to plot different types of graph. And note that this tutorial will not cover all geometric functions available in the ggplot2 package, and you are absolutely encouraged to explore more of them on your own using the single or double question mark commands. Or you can also visit this website right here that has more functions of the ggplot2 package. So the second geometric function that we are going to cover in this tutorial is bar graph, and we use geom_bar to do that. So geom bar only needs us to define either the x or the y aesthetic, not both. And this is because one of the axes needs to be the count of whatever variable we choose, because it is a bar graph. So for example, if we want to count how many individuals there are of each reported gender, we would need to write these quotes. And then also we can tell R to calculate the proportion of each gender instead of count by using this as the y-axis. Now we're going to go over some of the positions available for bar graphs. So remember the jitter position, that's only appropriate for scatter plots. Now we're going to go over the fill position, the dodge position. Okay, so first is fill. It lets us add another variable to our graph and further divides up our columns into separate categories. So for example, if we want to know the different combinations of genders and races in our data set, we would need to write these codes. And then this would be our output. Next is the dodge position. And this argument separates our columns into smaller side-by-side columns so that we can easily compare the different variables. So we would need to write these codes, and then this would be the output. Another way that we can choose to present our bar graph is in the form of a circular graph. So to do this, we can add another function, coord_polar, to our ggplot canvas, like this. And this is what our graph will look like with that additional function. So now let's move on to another geometric function to plot line graph. So this geometric function is geom_line. And just like usual, we will need aesthetics and then nest the x and y axes in the aesthetic argument like so. Line graphs may also be an interesting way for us to demonstrate ranges of a particular continuous variable of a categorical variable. So for example, we can see the range of systolic blood pressures of different races with the following graph. If you're not too big of a fan of the line graph above, box plots is another option that we can explore together. So to plot a box plot, we use geom_boxplot, like so. So this box plot tells us the mean, the maximum value, the minimum value, and the different quartiles of the systolic blood pressure of patients of different races. And here's another example of a box plot where we plot the distribution of diastolic blood pressure based on gender of the patients. The last geometric function that we are going to cover today is frequency polygon. So frequency polygon is another option that we can explore. They are similar to bar graphs, except they visualize the counts as lines. And we can use this function right here to plot frequency polygons like so. So this frequency polygon right here tells us how many patients have a specific diastolic or systolic blood pressure measure value. So the orange line shows the counts of different diastolic blood pressures, and the blue line shows us the different counts of systolic blood pressure. So that's why our y-axis is count, and our x-axis is supposed to be blood pressure, but it's currently not, and we'll learn how to fix that later. Since this function, geom_freg_poly, divides the variable in the x-axis into bins before counting the number of observations in each bin, we can further customize how we want our frequency polygon to look by changing what we call the bin width. So here's what the graph looks like when the bin width is 1, and here's what the graph looks like when the bin width is 20. So now think about what makes this difference and what this difference means. Okay. And we can also layer multiple frequency polygons on top of each other, like so. Note how the legend on the right is automatically produced by R and color-coded as well, if we use the color argument like so. Aside from using aesthetics, facet_wrap is another good option to create subplots based on categorical values, or variables. You can divide the data up into subplots by 1 or 2 variables. And here are what the two situations would look like. This is when we divide the data up into 1 variable, and this is what the output is when we divide the data up by 2 variables. Now think about which one of this tells us more information. What information do you think is meaningful and what is unnecessary? Do you see any correlation or relationship between any of the variables and factors? Now that this information is visualized, do you want to go back to your data and manipulate it even further? These are the questions that we should be asking when we are visualizing our data. And data visualization may come after data analysis, but it can also inspire further data analysis as well.